Of Chapter 10, Complex Experimental Designs for 3040 Research Methods. So let's take a look at these designs. Now, these are designs that all of you have been introduced to because some of you are already doing these designs in your research projects. So sometimes we have these different designs where we increase the number of levels of the independent variables. So you have a single independent variable, but it also has multiple levels. So there's multiple levels within the independent variable. When you add more levels to an independent variable, it provides far more information about the effects of those variables on the dependent variables, right? So it provides way more information that you can find than if you just had a single level of the IV. Now, when you're increasing the levels of the IV, you want at least 3 or more groups. You could use 2, but then you really don't have anything more than a t-test or just a between groups difference. You can use 2 or more groups, but typically we try to look for 3 or more groups when we start to increase the levels of an independent variable, particularly when we're only using 1. Now, at least at this level of your research experiences. Now, because you're adding 3 or more groups, you typically have some type of a curvilinear relationship, or at least that's your goal. When you have 3 levels or groups of a single independent variable at a minimum, you're going to get either a U-shaped or an inverted U-shaped, and in fact, that is, like I said, the goal. We're going to look at that in the next slide, so it'll make more sense in a moment. The test statistic that you use for this particular research design is a one-way ANOVA. A one-way ANOVA is used to compare the difference between 3 or more groups. A little bit more on that later. So let's take a look at some of the basic information of when we increase the levels of an independent variable. Now, this is still a between groups design because you're looking at the differences between groups, but in this case, you have a single independent variable, and we'll go through the example of this, but you have multiple levels of the independent variable. And here's that inverted U shape that I was talking about on the previous slide, but let's talk a little bit about this particular study. In this study, researchers wanted to find out if you mentally practice or did mental rehearsal of actually throwing darts across the room at a dartboard, would that somehow increase your dart throwing score? So here, the independent variable is your mental practice and rehearsals, the number of mental practice and rehearsals, and your dependent variable is your dart throwing score. So these researchers had 5 different levels or 5 different groups of people. In level 1 or group 1, people were told don't do any mental rehearsals. They were told nothing and just started throwing darts at a board to get a dart throwing score. The second level, independent variable level, was 25 rehearsals. So the persons were asked to rehearse in their mind 25 times, throwing the dart across the room to the board. Group 3 was asked to mentally rehearse 50 times. Group 4 mentally practice 75 times. And then Group 5 mentally practice 100 times, rehearsing in their mind, throwing the dart again across the room. And so we can see here, this is where their dart throwing score was. So let's take a look at the outcomes of this particular study. For people who were told not to do anything and were not trained on doing any rehearsals, well, they got a score of about 237, 236 on their dart throwing score. That's their dependent variable. But as you can see here, if you were in the group that mentally rehearsed 25 times, your score increased to about 247 or so. If you rehearsed 50 times, your score went up to 255, 75, pretty much about the same, 100 mental rehearsals, about the same. As you can see here, by providing 5 different levels of the independent variable, we were able to see a very nice, clean change and difference of that dart throwing score, the dependent variable, depending on how many times you mentally rehearsed, practicing in your mind throwing the dart across the room. Now let's imagine if we only asked participants, we only had 2 groups of participants, and we said, you guys just throw the dartboard, no mental rehearsal. We're not even going to talk about it. But then this group was asked to mentally rehearse 100 times. We would think on those outcomes, well, obviously throwing more, 100 or more, you're going to get a far better score as we see here. And if you only had these 2 groups, you would say, well, there's a significant difference. Looks like there's this big difference between no mental rehearsal or practice on the number of throws, you're like 237, versus 255 if you mentally practice 100 times throws in your mind, right? But with only these 2 levels, we wouldn't have captured this other nuanced information here. we were able to see that with this information of having 5 different levels, what really is the optimum level or number of times that you should mentally practice dart throwing. And in fact, the optimal time is right here, right? You can see that about 50 times. Because if you mentally rehearse 75 times or 100 times, it pretty much stays stable across time. There is no change in your dependent variable or dart throwing score whatsoever. So the optimal time is 50 rehearsals in your mind of actually throwing the dartboard, throwing a dart at the dartboard, if you want to increase your dart throwing score. This is the magic number. And again, we wouldn't have been able to see this if we only had, let's say, 2 levels of the independent variable. No mental rehearsal practice or 100 mental rehearsal practice. We wouldn't have been able to see that. We would like, whoa, that's a big change. But you really don't need to mentally practice 100 times throwing darts. You only need to do it 50 times because that's the magic number and you'll still get a relatively high score. And this is what we mean by the direction of the variable changes depending on the level or the number of times that you rehearse in your mind this particular dart throwing. And this again is that inverted U shape. And that's what you want. You want to see some kind of a change, either an inverted U shape or a regular U shape, which would look something like this, right? So you can look at these changes over time and the differences based on sort of what it is in the independent variable or the different levels of the independent variable that you're asking someone to do. So that's an example of having a single independent variable, but with multiple levels. Let's do another example of that. In this particular, another curve in the linear relationship, this particular study, researchers were trying to understand the energy levels of college students depending on the time of day. So here we have the independent variable as the time of day. Level 1 was morning, level 2 midday, level 3 evening, and the dependent variable was the energy levels, which you can also see here, low and high energy levels, which was the DV. Now, I want to note that just because we say morning, midday, and evening, sometimes we don't call these levels. Sometimes we call these time 1, time 2, and time 3. As you can see here, time 1 is in the morning, time 2 is midday, and time 3 is in the evening. So level and time are interchangeable. But typically when we're referencing a particular time of day, we will actually reference it time 1, time 2, time 3. However, in the dart throwing, this did not represent different time frames. It represented different experiences. And so we would call that levels within the IV. So here we go again. So what we see here is that in the mornings, level 1 or time 1, we see that college students have low energy levels. In midday, level 2, college students have high energy levels. And then at level 3 or at time 3 in the evening, we see that, and these are the results again, that college students have low levels of energy. Now, so it's very important sometimes when we have this single independent variable to break it up into multiple levels to try to find these nuanced differences. Because once again, and again, these are our 3 IVs, and it's important to, not 3 IVs, 3 levels of the independent variable. And it's important to do that because once again, if we only looked at morning, like when students went off to school, and when they get home, towards the evening, later at the end of the day, we would only think that college students have very low energy levels no matter what time of day it is. In the morning, they have low energy, and when they get home, they have low energy. By adding in 3 different levels, we can find this interesting nuanced difference that happens during the middle of the day. And again, we have a curvilinear relationship here. And so this is what we typically will see when we are running these types of study designs. When we have a single independent variable with different levels, we can graph the means of these different groups or experiences that participants might have, and we can look at these interesting differences. And that's why we want to add levels to our independent variables, because we can find information that we would not ordinarily be able to gain if we only had 2 levels of an independent variable. Now, moving on to another type of design that has to do with independent variable are the factorial designs. Factorial designs are designs with more than one independent variable. These are also known as factors, and in SPSS, when we run these factorial designs, you'll see that it references factors here. Here's an example of a 2 by 2 factorial design. When we call it a 2 by 2, right here, factorial design, we're saying that this particular research design study has two independent variables. This is IV1, IV2, with two levels each. And you can see the number 2 represents the level of IV1, and the number 2 here represents the level of IV number 2. So let's take a look of how that would visually be seen in a model. So here we have independent variable 1, which is gender, and you can either be male or female. So there's two levels of independent variable 1, gender, and you have independent variable 2, which is number of chocolate bars that you eat per week. So independent variable 2 is chocolate bars and per week, and you have one level, either 2 bars per week, and you have the second level of this IV, which is eating them 4 bars a week. Now, in this particular study, researchers wanted to find out over a period of 2 weeks between males and females, and depending on if they ate 2 chocolate bars a week or 4 chocolate bars a week, how much weight would they gain, or what would their weight be difference be between these two groups. And so here you could basically have in a 2 by 2 factorial design, there are 4 possible categories that participants could be assigned to, or could be, could these groups that they could be in. So you could be a male that eats 2 bars a week. You could be a male that eats 4 chocolate bars a week. You could be a female who eats 2 chocolate bars a week, or you could be a female who eats 4 chocolate bars a week. So with a 2 by 2 factorial design, you could just do multiply 2 by 2, you have 4. You have 4 different possible categories. Now, when we tease this out a little bit further, this particular category represents one condition out of 4 participants that they could be assigned to. So again, you could be assigned to this group, you could be assigned to that group, you could be assigned to male 4 bars, or you could be assigned to female 4 bars. You typically want 20, maybe 25, you can possibly get away with 15, but somewhere around 20 or so people in each one of these 4 possible categories for a 2 by 2 factorial design. So you really want at a minimum 60 to 70 people, but more likely something close to 75 to 80 people in your research study when you're running a 2 by 2 factorial design. So this is the general setup of what it would look like. Again, IV1, which is gender, has 2 levels, male and female. IV2 is number of chocolate bars per week, either 2 bars you eat a week or 4 bars a week. And this represents the possible categories that participants could potentially be in. A male with 2 bars, male with 4 bars, female eating 2 chocolate bars, or a female eating 4 bars. And again, when we tease this out more, each one of these 4 blocks represents a condition out of 4 that the participants could potentially be in. So this is just the basic visual model of a factorial design, and we've seen this before when we were helping you select your research designs. So here's another design with more than one independent variable, also known as a factor design. This is the same exact what you said, but let's look at another example. This is called a food intake modeling study, and here researchers were interested in trying to understand whether or not participants would increase the food that they eat when they're placed in a room with a research confederate. Remind you, a confederate is someone who is part of the research team, but they're pretending to be a participant of a study. So they wanted to see whether or not participants would increase their food intake depending on whether or not the confederates ate lower high number of M&Ms, basically had lower high intake, and whether or not the confederate was sociable or non-sociable. So let's take a look at this particular model, and then we'll look at the outcomes of this study. So researchers again were interested in finding out if there was going to be a difference in how much food you ate depending on the sociability of the confederate, of the person in the room with you, as well as whether or not the person or the confederate in the room with you ate a low amount of food or a high amount of food. So IV-A or IV1 was the sociability level of the confederate, so they either were sociable or non-sociable. If they were sociable, they said, "Hey, how you doing? Hi, it's nice to see you." They acknowledged you, they said hello. An unsociable confederate was someone who didn't acknowledge the other person, didn't speak to them, didn't give them any eye contact, and just not friendly at all. So these researchers, again, depending on whether it's sociable or unsociable, wanted to see if the participant would model eating behavior of a confederate based on their sociability levels. Now, independent variable B, or independent variable 2, was the confederate food intake. So did they eat a low amount of food or a high amount of food? So some Confederates went in the room and ate a low amount of food, and some Confederates went in the room and ate a high amount of food, depending on the independent variable here. So we have IVA or 1, Confederate sociability, and IVB or 2, food intake, low or high of the Confederate. So basically, participants could have been exposed to any one of these 4 conditions. This one would have been a sociable Confederate who ate a little bit of food, an unsociable Confederate who also ate a little bit of food, or a sociable Confederate who had a high amount of food intake, or an unsociable Confederate who also had a high amount of food intake. So you can see each one of these 4 categories here represent the exposure condition that participants could have been involved in when they walked into the room. Were they with a sociable Confederate who ate very little amounts of food? Or were they with a sociable Confederate who ate high amounts of food? Or were they with an unsociable Confederate who ate low amounts of food, or an unsociable Confederate who ate high amounts of food? So again, this is the general layout of this particular model when researchers were trying to understand, again, if a participant would model eating behavior of a Confederate based on their sociability levels. So let's take a look at the results of the food intake modeling study. And in this case, it did have to do with M&Ms. Some of you have taken statistics. You have seen this particular study before. So here's the outcomes of that study. And this is basically what we're looking for. So when a Confederate had low food intake or ate just a few M&Ms, and when they were sociable, then this is the dependent variable, the number of M&Ms that the actual participants would eat. So basically, remember those 4 conditions? This represents those 4 conditions that we just saw on this particular slide right here. These are the 4 conditions. So let's look at those dependent variable outcomes right here. When a participant was in the room with a very sociable Confederate who had low food intake, they ate about 6.58 M&Ms, 6.6 M&Ms. When a participant was in a room with an unsociable Confederate who also ate low or just a very few M&Ms, they actually ate far less M&Ms. So you can see here the sociability level of the Confederate seems to play a role here. So if you have a low amount of M&Ms being eaten by a Confederate, if they're sociable, you tend to eat more M&Ms. If they're non-sociable, you tend to eat very few M&Ms. Now, looking at this particular group, they were with a sociable Confederate who ate a lot of M&Ms, 5.68 M&Ms. However, if you were in a room with an unsociable Confederate who also ate a high number of M&Ms, then the participants also ate a high number of M&Ms. So we can see that there are some difference here in each one of those 4 conditions that we identified before. About 6.6 M&Ms, sociable Confederate who ate low amount of M&Ms. You would only eat 2.14 M&Ms if you were in the room with an unsociable Confederate who ate a low amount of M&Ms. However, you would eat about almost the same here, right? If your Confederate was sociable, you really didn't see much of a difference here. 6.58 to 5.68, regardless on low or high intake, the sociability was about the same. Interestingly, though, we see that when your Confederate is unsociable, there seems to be this interesting difference between the number of M&Ms that people ate based on whether or not the Confederate had a low amount of M&Ms or high amount. So again, if you're in the room with an unsociable Confederate who ate very few M&Ms, you also ate very few M&Ms. But if you're in the room with a very unsociable Confederate who ate high M&Ms, you also ate high number of M&Ms. So you can see this interesting difference start to take shape here. Now that's really looking at the interaction between these 2 variables, but let's take a moment and move to our overall means and main effects. So there's 3 things that we're looking for when we're running these 2x2 factorial designs. I just kind of wanted to show you the outcomes here based on those 4 grouping variables or 4 conditions that people could be in. But generally what you're looking for here, you're looking for the overall main effect of independent variable A, in this case, Confederate sociability. When we take the average of these two means and the average of these two means, we're just kind of looking at, the sociability levels seem to play a role in the number of M&Ms that you eat, just looking at this independent variable by itself, not with this Confederate food intake, but just the sociability level when we average these out and we look at these means. Nah, from this perspective, it doesn't really look like much of a difference. But again, these are the overall means or main effect of independent variable A. So you eat about 6 M&Ms on average if you're with a sociable Confederate, and 6.39 M&Ms on average if you're with an unsociable Confederate, regardless of the number of M&Ms that you eat. We're not taking this into consideration here. We're just looking at the number of M&Ms that are eaten in each group depending on the sociability and unsociability based on these averages here. Now, the second thing that you're looking for in a 2x2 factorial design is the main effect of independent variable B. In other words, how many on average M&Ms are consumed when your Confederate eats a low amount of M&Ms. It's about 4.36. And again, this is the average here, going across low here. And this is the average number of M&Ms that are eaten when the Confederate food intake is high. Again, the average between 5.68 and 10.63 is 8.16. So we're looking to see if independent variable A has some type of an effect on the number of M&Ms that you eat. So we're looking at this difference here. And we're also looking for main effect of independent variable 2, or in IVB, just based on the Confederate food intake, low or high. And we can see that there's starting to be this interesting difference here. There seems to be, depending on whether a Confederate has a few M&Ms or a lot of M&Ms, then it will change the number of M&Ms that the participant does eat, which is the dependent variable. The third thing, so this is the two things that we're looking for, main effect of IV1, main effect of IV2. The third thing that we're looking for, right, we're looking for that significant difference here. But the third thing that we're also looking for is that interaction. What is the interaction? What happens when we take a look at IV1, Confederate sociability, and IV2, Confederate food intake together? What is the interaction? What happens when we put all these together? And this center box here speaks to that interaction. We start to see these interesting differences take shape right here based on these means. Okay. So basically, factorial design interpretations, moving away from the results of that particular study, we're basically looking for a couple of things. Number one, we're looking for the main effects of both of the IVs, or the independent of the other factor, on the dependent variable. So we're looking for the main effect of an IV on the dependent variable regardless of the other factor. And we're doing that twice, right? We're looking for main effect 1 and main effect 2. The other thing that we're looking for is the interaction between the independent variables. What happens when we put sociability of Confederate level together along with the amount of M&Ms that were eaten at the same time? This is not an option when we're doing single IV experiments. This is only something that you would interpret and do when you have multiple independent variables. When you're looking at these main effects, you're doing nothing more than an independent sample t-test, looking at the differences between two groups, but the interaction is looking at all these different conditions and how they operate together. You could also have something called an IV by PV design, where the independent variable is manipulated by the researcher, but you could also have something called a participant variable. This is something that's non-manipulated and something that the participant comes with. Some of you have IV by PV designs because you're looking at something like gender or ethnicity, right? And in fact, an IV by PV design, as another example, let's go back here, is this particular study. This is an independent variable that's manipulated by the researchers, the number of candy bars that they're asked to eat each week. But this is a participant variable because this has to do with gender, something that the participants come with. Gender, ethnicity, sexual orientation, all of these different participant variables is what we would call them. So moving right along, after our interpretation of our results, so let's get back to this place here. I just wanted to show you IV by PV designs. Some of you are operating those IV by PV designs. We want to look at the interaction between the IVs, right? And so when we're running a main effect, we're just basically looking at if there's a statistically significant difference between the means of the IV. However, when we're looking for an interaction, we're trying to find out if there's something happening with the IVs together. Here we have the number of M&Ms consumed, and here we have the sociability level of the Confederate, right? Confederate sociability level, whether they're sociable or unsociable. Everything in green we have as when the Confederate has low food intake, doesn't eat a lot of M&Ms, and then orange is high food intake, whether or not they eat a lot of M&Ms. And we can see this interesting interaction take shape. The one thing about the test statistic that you'll run with a 2A, with this particular research design, which is a 2A ANOVA, it'll tell you if there's an interaction, but it won't tell you where. So you'll need to look at these different bar graphs to try to find these out, or you can look at line graphs as well. So you're looking for these interesting interactions between the independent variables, and you can kind of see this already here. And we saw this in that center design here. This is basically what you're going to see on that bar graph is the graphing of these particular means right here, because these means represent the interaction. If you're with a sociable Confederate who eats a low amount of M&Ms, then you yourself eat about 6.5 M&Ms, so on and so forth, as we've described before. So moving back to that particular bar graph slide, let's take a look at this. Again, if you're with a sociable Confederate who has low food intake, you eat a little over 6 M&Ms. If you're with a sociable Confederate who eats high food intake, those participants are eating just under 6 M&Ms. Maybe it was like 5.86 and 6.5. So they were relatively the same. However, when you're with an unsociable Confederate who eats low food intake, then you're eating just over 2 M&Ms on average. When you're with an unsociable Confederate who eats a lot of M&Ms, then those participants are eating well over 10 M&Ms. So you can see this interesting interaction. Another way to look at this is kind of looking at these different variables together. When you're sociable with low food intake, we see it go from high to low. And when you're sociable and unsociable, depending on how you're experiencing that, sociable and unsociable, you kind of eat less M&Ms. But when you're someone who is not sociable, you eat a higher amount of M&Ms. So you can see these low to highs happening along these IVs, but you can also see the low to highs happening between the two variables here, sociability and unsociability, as it relates to low and fight intake. This is the one that's particularly of interest for us, right? We can see when a Confederate is unsociable, it does make a difference on the number of M&Ms that you eat. Also, not just that they're unsociable, but also whether or not the Confederate ate a few amount of M&Ms or ate a high amount of M&Ms. When a Confederate is unsociable and eats very few M&Ms, then the participants eat very few M&Ms too. If you're in a room with an unsociable Confederate who eats a lot of M&Ms, then guess what? Participants also eat a lot of M&Ms, well over 10. So you eat from 2 to 10, and this is an interesting interaction effect that's going on between sociability level and the food intake as well. So 2x2 factorial designs, you're basically, again, as a review, determining the significant effects of the main effect for IV1, that's also known as a factor. You're looking for the main effect for IV2. Again, that's also another factor. Again, you're just looking for the main effect of those independent variables by themselves, disregarding the second independent variable. This one, I'm looking for the main effect or the significant difference that exists between those differences in IV2. And again, looking here, is there a significant difference or main effect between males and females as it relates to dependent variable, and in this study, weight gain or weight changes. Main effect for independent variable 2 is chocolate consumption. So again, is there a significant difference in weight change based on the number of chocolate bars that you're asked to eat? If there's a difference between eating 2 bars a week versus 4 bars a week, is there a significant difference in weight change, which again is the dependent variable? So you're looking for main effect of gender and the main effect of chocolate consumption. The third thing that you're looking for, again, is that interaction between the independent variables. What is the outcome of weight change when we take a look at not only the chocolate consumption, but also your gender as well, taking into consideration whether you're male and female and how much chocolate you might have eaten, then what are the impact of both of these independent variables interacting together? How do they influence or have an effect on weight change, the dependent variable in this particular study. So you have several potential outcomes, and there's a couple of slides relating to this. And what I mean by several outcomes, right? When you have A and B, this is the main effect for A or 1, main effect for B, and then your interaction A and B. So you could have no main effect or no significant difference for IV1, no significant difference for IV2 or B, and then you could have no interaction. You looking down here, you could have a main effect for IV1, you could have a main effect, yes, for IV2, there is a significant difference, but again, no interaction. You could have yes, no, no, you could have no main effect, yes, a main effect, no interaction, and so on and so forth. This is helpful because when you're running these particular statistics, you're going to ask a SPSS to provide you with a line graph, and you should also ask them to provide you with a bar graph. And you can use this as a reference to kind of understand, oh, okay, I do have a main effect for A and B because we can see these differences here, but there really is no interaction. So you can look at those line graphs and get a sense for whether or not you have an interaction, yes or no. So going back to that test statistic, as I mentioned, it's an analysis of variance, specifically a two-way ANOVA in SPSS, which is trying to understand both the simple main effects of the independent variables as well as the interaction. Now, when you get your results and you interpret results of your factorial design, it's customary to review the results of the interaction first, because really this is why you're running this ANOVA. The whole goal of these research studies, when you have factorial designs, when you have more than one independent variable, it's really to look at the interaction. How do these two independent variables that are operating together, how do they influence and interact how do these two IVs work together to have some type of an effect on the dependent variable? And that's the overall goal of a two-way ANOVA. You know, the simple main effects are helpful. And the simple main effects are useful, especially if you don't get a significant interaction. You could report something. But ultimately, really, this is the ultimate goal when you're running a between groups 2x2 factorial design. You're really interested in trying to understand what are these nuanced differences and outcomes of the dependent variable when you include two different IVs together. So you're really assessing the statistical significance of both the main effects and the interactions, but it's the interactions that are really of value and important here. Other factorial designs, you can use factorial designs with an independent groups design of between subjects like we were just looking at in most of the studies that we used as an example, or you could use factorial designs with the repeated measures. Repeated measure designs are, remember, when you have a group of subjects, you give them a pre-test, you give them an intervention, and then you check a post-test. So you have a pre-test, post-test design. They're basically being exposed to the experience time 1 and time 2. You can also have a mixed factorial design where you're combining an independent groups design and a repeated measures design. I have absolutely had students that have run this before where they're looking at the differences between two different groups, but each group is receiving a pre-test and a post-test as well. So that's what we mean by that. And just as a quick reminder, this is what we mean by independent groups design and a repeated measures design. And again, here you have in an independent groups design, you have two independent groups of people, and you're looking for the differences between these two groups, also known as between groups designs. You have an experimental group and a control group, and they are all very different people. They are not the same. But with a repeated measures design, everyone is the same. They get exposed to an experimental condition and assessed, and then they're assessed again sometime thereafter. So you compare the scores of the sample from the two different conditions, the two different experiences, sometimes known as the pre-test and the post-test as well. But everybody is the same. Okay, so factorial designs, you can continue to increase the number of levels of the independent variable. You can increase the number of independent variables within the design as well. We saw some increasing the number of levels of a single IV. You saw one that had 5 different levels. You saw another study that had 3 different levels. A lot of you are working this one as well. Some of you are working this with 3 different levels of the independent variable. But you can also, again, increase the number of IVs in the design. That's basically what factorial designs are. But the designs do become much more complex when you add different levels of the IV and when you increase the number of IVs, because it requires more numbers of participants. As I said before, as I referenced before, with some basic studies, you could probably get away with 25, 30, maybe 30 to 40 participants. But when we start working at more complex designs like factorial designs, you need to have a certain number of people, really magic numbers, probably about 20 in each one of these categories. So in this particular study, which is a 2 by 3 factorial design, you have two independent variables. This independent variable stays with gender as we saw before, which has two different levels, but now we're adding this third level here. So we have independent variable 2, which is chocolate consumption, 2 bars a week, 4 bars a week, aha, but now we have another level, which is 6 bars a week. So you could be male eating 2 bars, 4 bars, or 6 bars, or you could be a female eating 2 bars, 4 bars, or 6 bars. And this is what we would call a 2 by 3 factorial design. And again, some of you are operating this particular research design as well. But again, given that, you need to know that you probably will have somewhere between 100 to 125 at a minimum people in your study for this to work statistically. This was just an example of that IV by PV design, or just another example of that looking at it. So I'll let you take a look at that on your own. And again, here's another example of ways to looking at these interactions. This was a study on extroverts and introverts and their reading comprehension, whether or not they were silent or in front of the television. And again, this is an IV by PV design example. Participant variable is whether you're an extrovert or an introvert. It's something that you come to the table with. But the independent variable too here is also this distract condition, either in silence or television. And this was manipulated by the researcher. So again, just a couple of other examples of a 2 by 3 design and looking at what you would be looking at for IV1, IV2, and the outcome variables, and then an example of an IV by PV design for your review. Okay, thank you everyone for watching.